Good afternoon, everyone. I hope you guys have a great day so far. Give me one moment. Let me just put in my notes. Okay, last time we were doing these things over here. We're talking about stem and leaf. So now we're gonna be talking a little bit more in depth about the visualization process, the one on which we're gonna try to visually express a data set. So let me just put a couple people in. Give me one moment. Let me see. One moment. Okay. See. Okay. So let's talk about these things. Give me one moment. You see. Okay. People are sitting in the waiting room. Okay, so whenever we talk about we do have something called a distribution. I think last time I spoke about a frequency distribution, and I did express the idea that we need to have some type of shape, like a bell shape, something like that, and we're gonna say this is symmetry or not. So let me just right here, go ahead. So let's do this one. I'm gonna find my pen for some reason. Where are you, pen? Okay, so right here. Okay, now there he is. So we need to have a distribution in which we were looking for something like this, like a bell shape, okay? Can be symmetry toward this is center, okay? So that's mean this side right here, this side right there is kind of the same thing as the other side. So let me just use a different color for that one. Let me just do it one more time. So we can just do this. So you got one side, that side. The left side is kind of repeated on the right side. It's kind of a symmetry. That's what we're talking about here. And the right side right here is kind of symmetry. Okay. One is, I mean, it's symmetry with respect to this axis of symmetry as the median, or with respect to the line, the vertical line that you see right there. Okay. So that's why I want to talk about. So let's see that about. Say whenever you have a shape, we're talking about symmetry. That is very important. And then this one say how many bumps or modes. Sometimes you might end up having a data in which there is no. I mean, you can have like something that repeat like this. Let me just. I keep losing my pen for some reason. Oh, it's right here. You can have something like this. Well, I'm sorry, I'm losing my pencil. Okay, there it is. In some data, you can have something like this, a bit like this. Okay, that's meaning you can have like many bumps. All right. And then you got some bumps like that. Okay, and then it repeat itself. Okay, so here we have 2 bumps, and sometimes you can even have 3 bumps as well. But as long as you have a kind of a symmetry, then that's something important. So the bumps, we also call them modes. Okay, and then some other features. So the center is very important. So we're gonna be talking about typical value. A typical value is something that we can really calculate it, and that will give you an idea of the entire data. Typical value can be a mean, median, mode. No, not mode. It can be a mean or average, median. That's why I call a typical value. Okay, mean, median. The mode might not be a typical value because you might not be able to calculate exactly, but that's what it means. Okay, so and then also we're talking about something called the spread of the data. Give me one moment. I think I hear some noise. Okay, with the spread, we'll be talking about something called a variation. Okay, we're talking about something called variation. This will give you how the data vary. Okay, so if it's close to each other, if they are very close to each other, you're gonna talk about something that you're gonna say this is there's a small variation. If they are very close to each other, you're gonna say there's a small variation. Okay. If they are spread out, I mean the variation is like you have a higher variation here. So this one looks like a higher. Okay. So let's see. So there's something also called skewness. That is also very important, an important concept that we need to talk about. Okay. For the skewness, you have something that can be skewed. So if you have the specific graph like this, and then you have a tail, and then you also can have something like this. Okay, and you have a tail on the left side. So here we have a skewness on the left side. Left. Oh. And that's how you're gonna say this is like left is skewed. Left. Okay, and this one is on the right side. Okay, compared to the one that we had earlier, in which we have something like this. Let me see. Let me just erase that. So we have this one right here, in which you have like the symmetry one. That is the one that we are talking about. So we have simply symmetry, but this one is skewed. Okay, this one right here is skewed. Okay, the other one also is also skewed. Okay, but this one is not skewed. This one here, we have a bear shape. Okay, you have a bear shape here. So example right here, I can just show quickly an example. So this one say this distribution is skewed, right? If most of the data value are small, and there's a tail on a larger value to the right side. Okay, so you're gonna be skewed to the right. Okay, so let's look at the example right here. Just like I said earlier, you have a right here, you have a right tail. Let me just erase that so you can have it here. You can see better. Next, I'm going to have to create a couple empty slides so I can use it here. We have a right tail. So the tail is on that side. Okay, so therefore this one is say this is skewed to the right. Okay, and also on the other side, this is also skewed to the left. Just like we said earlier, this is left right here. What does that mean? If most of the data value are large, and there's a tail of smaller value to the left. Okay, so the only thing that we need to understand here is to understand what is something that is skewed to the right. You need to identify shape that are skewed to the right and skewed to the left. Okay, that's what you have to do right here. Okay, there's no really something to really grab out of it. You should just say, is this, which one is skewed to the left, which one is skewed to the right? That's what you're gonna have to do. Okay, so that's gonna be in this part right here. So whenever you see the graph, okay, so you're gonna look at the tail. So if the tail is on the right side, you're gonna say this is skewed to the right. If the tail is on the left side, you're gonna say this is skewed to the left. Okay, and if you can also do a better shape of it like this, something like that. Okay, as you can see, the second one is also skewed to the left side. Okay, so it means that most of the data value are large. Okay, and there's a tail of smaller value to the left. Okay, that's what you have to remember on that one. So let's keep working. Here we're talking about the symmetry also. We talked about before, if the left hand side and is roughly the mirror of the image to the right hand side, then this is symmetry. Here we have the symmetry right here. So if we do, create an invisible line right here. So this, the left side and the right side mirror each other. Okay. So here also you can talk about symmetry also right here at the center right here. Oopsie. They also mirror each other. Let me just draw a line instead. That'd be faster. That's fine, just use this one. Okay, so here you got the same idea. At the center, we have a symmetry. The left side is the same thing as the other side. Okay, so that's what we call symmetry. All right, but whenever you're doing statistics, we want to have something like this, done like that. Okay, this is the ideal thing we want to work with. This is what all of the law of statistics are working fine, but this one not really. Okay, for you to use the other shape, we have to make something called non-parametric statistics. So this is our statistics we're gonna be seeing in your class, but you can hear about it, but you're not gonna be able to use it for that specific kind of shape. Okay. Any questions so far? Okay. So I still have more people waiting for me. Okay. So now the next thing we're gonna be talking about is it's like you're gonna see everything's like redundant. We talked about them before, then talk about them again. So let's talk about this one again. Let's see right here. So whenever you have only one tip of the model, we're gonna call this one a unimodal. That means we have one model, one mode, or unimodal. It's because you have only, whenever you have the graph like this, the bear shape, you have only one peak right here. So this is called one mode. Okay, or you can say one mode, and at the same time we also can say bumps. You can say you have only one bump. Okay, that's a bump. All right. In some other case, you can have more than one bump, like this one. If you have two bumps, it's called a bimodal. As you can see, this one is not really symmetric, but the idea is that we just want to know about bumps here. So here we have two bumps. Okay, so this is bimodal because you got two bumps. This one right here and this one over there. So you got two bumps. Okay. And then you can have more than one bump. So in that case, you're gonna say if you have more, usually if you have more than one, it's called multimodal. Also, that's mean everything from here to there is also called multimodal. Okay, this is multi. Even though it's same bimodal, it's also multi. Okay. So here, it is an example right there. They showed right. So I know that this one relationship really show that the idea we want to talk about. But if you do the graph for that one, it means something like this. You go up, down, you go up again, down, then you go up again, down, and then go up a little bit, and then down. See here, yeah, this is why you call it multimodal. You got more than one mode. Okay, so let me just do the graph one more time, because you got two of them here. You go, you see, you go up, down, up again, up again. Yeah, I will do the first way. And down, up, down, up, down. Okay. So here we have like more than two modes. Okay. Okay, you got more than two modes. That's what happened. In that case, this is two modes right here, two modes. This is multimodal. If it is more than two, I would like to say more than one. By definition, it's more than one. It's called multimodal. Okay? It's called multimodal. Okay? Here we can say we have three modes because this one has the highest frequencies. But don't worry about it now. We're going to talk about them again in the future. Okay? Any questions so far? Okay. Then a very important concept is called a normal distribution. Okay. With the normal distribution, we want to have the bell shape. Okay. And then it has to be symmetric. It has to be unimodal. That means you have only one mode. Okay. And you have to have that bell shape. Okay. So we have one mode. So this is the only time I can talk about normal distribution, which is one of the main cause of what I'm going to be seeing in the future. Normal distribution. It has to be symmetric. It has to be unimodal. It has to have a bell shape. Okay. So that's mean if I'm looking at earlier version here, the only time I can talk about normal distribution will be in the following case. I cannot talk it for the third case. I cannot talk about it for the second case, but only can talk about it for the first case here. This is the only time I think talk about normal distribution. Okay, so it has to be unimodal. If it's not unimodal, you cannot talk about normal distribution. That's why I told you earlier. If it's not unimodal, if it's not symmetric, we're gonna have to use another type of statistics, which is called a non-parametric statistic. What we do right now is parametric statistics. Okay, but it has to be that we have to find a specific pattern. If not, we cannot use the law of statistics based on unparametric one. We cannot use them. It has to be that specific. That's all we have to know right now. We have that shape. That's what we need. Okay. Sometimes you can have something called an outlier that can stress the shape. An outlier, I think I spoke about it earlier. You can make the shape. You can make the shape really wide. Okay. If in the case of an outlier. So you're gonna think that there's more variation. Sometimes there is not. Sometimes you have to remove the outlier. Okay. Sometimes the reason of an outlier can be something that you put in error. It can just do the data itself. Okay. Here they give an example of owner who's making a lot of money, but all of his employees are making so little money. If you include the owner's income, it's gonna seem that everybody's making well. but which is false because only one person is making so much money. So this is what happened. And a normal thing, you're gonna have something like this. You got that specific graph, right? There's no outlier here, no outlier. But for the same data, so if you have an outlier on it, it's gonna make it outlier. If you're gonna spread it, it's gonna make it a little bit like, it's gonna spread it all the way like this. You're gonna stretch it, very stretch it. You make it look like there's more variation, something like that. Okay, as you can see, one look more like compressed, the other one look wider. Okay, it's look wider if you have the outlier. Sometimes you have to move the outlier. Okay, we talked about it earlier today. So if I can remember where I put it, let me see my notes. Just today we should talk about it, outliers. Whenever I talk about variation earlier, whenever I spoke about variation, so that if you have so many outliers, this will affect the shape of the data. So the variation will change. Okay, sometimes you're gonna have to remove it. All right. So these are some common thing that that we have an outlier for, is because sometimes there's an error on the data set, or if there's no error, it can be like just nature, or it can be like just like example say over here, or owner whose salary could be an outlier if the rest of the employees are all have low wage workers. That's everybody doing everybody have very low income. Only one person is doing pretty well. Okay. All right then. So next thing, the center. The center is kind of a typical value. What we like to use for center mainly is the following thing. I kept losing my cursor again. Okay, just before I know we're going to talk about in the future. For center, we like to invoke something called the mean, the median, and also mode. We like to talk about them. And then something called also mid-range. Okay, we're going to talk about them in the future, but not now. Oops. Wow. Okay, so that's center we're going to be talking about. That's the idea. Mid-range. The mid-range. Okay, I'll be talking about that in the future, but now let's talk about an idea. So we talked earlier. We talked about the typical idea, a typical value. So here, this is the common thing that we're talking about. This is when we use the normal distribution. Somebody has a question? Let me see. Okay, I see that. Somebody say, does the amount of modes determine the what? Does the amount of modes determine the skew? Usually, for the skew, you're gonna have only one mode. Okay. The mode we know is something else that's gonna be for the mode. It does change the shape of the data, but mainly we talk about skewed, and like what is skewed whenever you only have one mode. Okay. So just like earlier, for the skewness, is only have one mode. The mode is not really related to the number of mode, but easily for the skew, we only talk about it whenever you have one mode only. Okay, one mode. Because what happens is that the data, if you look at the bell shape, which is this one right here, okay, this one is not skewed because this is symmetry. With the mode, with the skewedness, you're gonna have one that's gonna have a left thing like this, and then the other one that's gonna have a right thing over there, something like that. So it kind of follow the same pattern with one mode, okay? But not necessarily that the number of mode will determine the skewness. Okay, so I do not have official and on campus right now because I'm doing the Zoom in class. I'm doing the Zoom right now, so I can meet with you after class one-on-one. Okay. Okay, so here this one say there's a typical value. Okay, I just told you earlier this typical value we talked about it earlier. Here we got a typical value at the center. That value here will represent the entire data set. All right. So if you have a data set, it does represent the data. You have a full of data. So you have a specific center of value right here. Okay. But compared to this one, which let me see. So compared to this one right here, let me just put the graph for you. Here, we cannot say we have a typical value here because you don't have that bear shape. Okay. This one is bimodal or skewed. So remember, we only want to work with the unimodal here. That's the one we want to work with. Okay. Anything else would be like kind of not really a good idea. Okay. So for now, we're gonna say whenever you have that bell shape, we're gonna have a typical value at the center. That typical value can be the mean, median, mode, or mid-range. Okay. So the mode can be only one value, or it can be just only one value in that case. In the other case, as you can see here, we have like two modes. It goes like this. It goes up, then go down. Not really down, but it go up again. Okay. So you have two modes here. Okay. So you say the center is not a typical value for the data set. All right. Compare here, we have only one mode right here, which is the thing that we're looking for. We want that unimodal. Okay. For now on, if you have the unimodal, you can have a typical value. If you don't have a unimodal, you're not gonna say typical value anymore. We don't want anything of whenever it's skewed or to the left of we don't want that. We just want the unimodal. Okay. Let me see. There are two more questions available here for me. Yeah, we say two modes for bimodal. Okay, two modes for bimodal. Two modes for bimodal. Just use that. Okay, so anybody, I'm looking for the questions. Any other questions? Okay. So let's keep walking. Okay, I thought there are more questions. So no more questions. Okay. Okay, now, so let me see. I think I skip one step right here. We just talk about, okay, now let's talk about the variability. Just like I told you earlier, it can happen that your data can have, I mean, but based on looking at these two graphs, so this one here has a high variability. Okay, we talked about variability before. This one has a low variability. So by looking at the bar graph, the numbers, as you can see, they are very low numbers. That's one of the things you can see. This is just a visual idea of whether I can just put them and say which one has low variability, which one have high variability. So by looking at them, you can see that the next one, the one on the right side, has high variability. So this is just idea that you can just just basic logic, okay? Just basic logic. Then you can understand. Okay, so in the exam I say, oh, which one has a low variability? Then you can select the first one compared to the next one. Okay, and also I can use either the bear-shaped idea, then do the same, to do the same concept. I know here we don't really have a bear shape, but just because they're not bear shaped doesn't mean I can ask question about it. Okay, so I can just ask a question about variabilities, stuff like that. There are the question can use, but to do real calculations, we're gonna have to use the bell shape. Okay, I know somebody say probably this one is on the bell shape. This one, the one on the left side is left skewed, while the one on the right side is also right skewed. Both of them are right skewed. Yes, but just to do a specific type of question, I can talk about variability. I also can talk about this one. I can say, how many mode do you have here on the first one? You're gonna say one mode. Okay, how many mode on the one mode? Okay, so this doesn't, I mean, just because it's not a bell shape doesn't mean I can ask a question about it. Okay, so just want to point out that idea quickly. All right. So again, so what we just talk about shape of a distribution. Again, we want it to be symmetric. Okay, for it to work out, but you can also have skewed. Okay. And also we talk about unimodal, bimodal, and multimodal. We spoke about these things. And then normal. This is the normal distribution. For the normal distribution, you want it to be symmetric. And then after that symmetric, one mode or unimodal. And at the same time, you want it to have the bell shape. Okay. So that's very important to have that bell shape. Okay. So if you have outliers, this can change the shape of the distribution. You can make it wider, or if it doesn't have an outlier, you can make it normal or smaller. Okay. And then the center, we talk about something called the center as well. The center can be either the mean, the mode, or the median, or the mid-range. We're going to be talking about those in the future. So we want them to be a typical value whenever you use that. We also, only whenever we have that one mode thing, whenever you have that unimodal situation. Anything else it's not gonna be a typical value. Okay. Oh, yeah, right here, see? So that's what we talk about here. We also talk about low and high variability. Again, low the variability, I can also use any type of graph that I want to. It doesn't have to be specifically the unimodal one. It can be any type of graph. So pay attention to these things as well. Okay. So the case in which you have symmetry, again, for symmetry is something like this. Let's see, symmetry. Like whenever you have a bell shape, the skewed can be like a left skewed. Okay, so let me see. Something like this. Like this, that's his left skewed. And neither is symmetric or skewed can be something like this, in which you have like the a graph like this. I can say we have something like this. See that? Something like this, that'll be neither. Okay. And they say, but it's not, if you put a line at the center, is not symmetry. Okay. So let's put a line at the center here. It's symmetry. This one is like skewed. I don't have to put a line between it. So this one is neither. Okay. We talk about also unimodal, in which you have only one mode, and bimodal and multimodal. I talked about this thing before. Okay. So let me talk about, let me go back to the bar graph idea. I know we spoke about bar graph earlier. So let me talk about the bar graph one more time. So again, the bar chart or bar graph is like a histogram, okay? But the recent axis can represent categorical data. Nature order may not occur. So again, this is just definition. So do not need to worry about the definitions. You just want to know about the concept, and then we are allowed to use notes. And so what we do, we just do the work, okay? So this item probably can be just read on your own, understand the idea. So, but mainly I'm just going to be do just the math portion we're going to be doing. There are some instances in which I can ask you some questions, logical questions. Okay, I can say, is a bar graph a type of pie chart, is a histogram, something like that. Okay, but you need to just use the notes and read them. I will put the notes for after class. Okay, here this is a frequency table. We talked about frequency table before. In which we have for private, you got 65, cat for you got 22, sergeant is 49, major is something like that. Okay. So we can also create a bar graph for those to see how it look like. So this is what we're gonna do. Let me just, I don't have space for it. You can do something like this. And then let's put the F right here. The highest number that we have is 65. I can say this is, for example, this is 50. And this is 25. 75. Something like that. Okay, you just have to be perfect. But you have to respect that ruler. Okay. Now let's see. For private, I'll put P for private. For private is 65. 65 is kind of like under 75, kind of in between. So I'll do a bar graph like this. And then for corporate, I'll put C for corporate. And then I'm going to put 22. 22 is like under 25. For sergeant, I'll put S. Then I'll put 49. 49 is like close to 50. Okay, and then for major, it's going to be under 25. M for major, something like that. And they're going to put under 25. Okay, so this is what they call a bar graph. It gives you an idea of the data set. Okay, so it looks simple. So you can see that I know the number is usually we put the numbers together and stuff like that, but I know here I just use just the frequency here. Sometimes you're gonna have to calculate it yourself, but you can see the private has more people, more members, and then the one with the least members is gonna be the major. We talked about that one before, but it's just how we qualify with it before about the bar graph. Okay, and so again, this is called is a graphical summary of categorical data. So this is categorical data here: private, corporate, sergeant, major. Or this is also a class. You can also call them class as well, but here is categorical. So this type of class is categorical. Okay. So again, definition that you can read on your own. Okay. So this one is category is written by a bar, the height of, so we just did these things. But it said the height of each bar is proportional to the frequency of the category. There can be more than one choice of ordering the categories. Okay, so and I'll show the graph right here. Okay, this one say the corporate is 20 something. What was it again? Corporate is 22. Okay, so he put it that way. So he put, and this one is put in order. But the idea is the same, okay? This one has put in order. What I didn't put in order. I just put the way it was given to me. This is also fine, okay? Any question about that? Anybody lost?
I have a quick question. Can we have access to the recorder? Like if we need to go back and watch the class, can we have access or just the notes?
I think about it. I can make it available for you. Yes, if it's a difficult class, then like the beginning, probably yes. But after all, I won't put it. Okay, I can do that.
Okay, thank you.
Okay. All right then. Any other questions?
Yes, so I just got my person code and then I made my account and everything, but then it asks for a class ID or PAN. So I was just stuck in that part.
Okay, can we talk about it after class, this one?
Yes.
Okay. So who am I talking to? That was Alexandra, right? Who just spoke to me? So I can remember. Who just spoke to me about the code? Is Alexandra?
No, it was me,
About-
Jenny.
Jennifer,
So-
okay.
Yeah, about the recording with me, Moniz.
Okay, so Jennifer is the one about, okay, so I remember to put you and we can go together after class, okay? I'll show it to you because on the first day of class, I did show you how to access your Pearson. Okay. Okay, then, so let's see, let's keep walking. So here, this one's, there'll be something called also Pareto chart, okay? So the Pareto chart, it ordered the frequency from smallest to highest. As you can see here, once you order from smallest to high, from smallest to high, from largest to smallest, this is called a Pareto chart. It's the same graph. The only thing, the only difference is that we make sure that to put them in order of frequency. Okay, so here, as you can see, the first one here is 65 for the business for private, then all the way to the smaller one, which was 16. Okay, this is called Pareto chart. Once you do that order thing, then you become a Pareto chart. It's still a bar graph, but it's called a bar chart. It also happened the same thing for histogram. If you have a histogram, if you order them in terms of frequency, it become a Pareto chart. As long as you do frequency order, this become a Pareto chart. Not only for that one, it can be for any type of graph you're doing. Okay, so if you put them in order frequency, it's going to become a Pareto chart. Okay, so that's why at the beginning I told you that it doesn't really matter. I put this one in terms of here because the categorical, right? You cannot say corporal is bigger than major, like on number 1, 2, and 3. There, that's why the categorical. Okay, it's best for categorical data like this, like if corporal, major, private, sergeant, that distant people. It's best to use what they call a bar graph. Okay, not a histogram, but bar graph is the best one thing to use for those. Okay, because they are very distinct elements. All right. So again, that Pareto chart is a question exam. I can say which one is the Pareto chart. I'll give you a few examples. Then you're gonna say which one it is. Okay. I can say, is this a Pareto chart? I do something like this. And I'll do something like that. And I'll do something like that. And I put A, B, C. Everybody can say B is the Pareto chart because it goes from highest to smallest. Okay, that's a Pareto chart. Something like that. Okay. Okay. The difference between bar chart and histogram. So histogram display numerical data. A bar chart can display categorical data. I don't really fully agree, but you can also use the bar chart for something else as well. For histogram, mainly histogram mostly has to be numerical. That's the main thing. Histogram has to be numerical. Okay. A bar graph can also be used for numerical, but it's best to be used for categorical data. Okay, you cannot use histogram for categorical data. Okay, and the example, if I say, can I use histogram for categorical data? You're gonna say no. Okay, histogram only can be used for numerical data. Okay, it has to be numbers for histogram. Okay, a bar chart or bar graph can also be used for numerical. We did it before. That was the thing we were doing last class. Okay, and that's how I was able to introduce to you the histogram. Okay. So this also definition that you can read on your own. The bar width of a histogram are meaningful and must all be the same size. The bar width for a bar graph are meaningless. Okay, so as you can see, so let me just show it to you quickly. Yeah, I do have space here. Do have space here. Okay, I think I'm gonna try to squeeze it there on top here. So as you can see, if you see the bar graph, okay, and I put let's put this one right here that was corporate and something like that, and put any numbers for now. Let's put B and let's put D. Okay. Okay. So compared to the histogram, this is the bar. Compared to the histogram, when I do the histogram, the width of the bar is important to me. Suppose I say this is 0, and this is 9, or this is 10, and then that'll be 20, that'll be 30. So the length here means that there's a width of 10 for each one of them. Okay, each one of them got a width of 10 because between 20 and 30. If you put it smaller, you have more details. I can put it by 5 if I want to. I can say this is like 0 to 5. Then that'll be 10. Then you got more details you're gonna be able to see here. So in that case, the width is smaller. Okay, the width is smaller, something like that. Okay, so but for the bar, whenever I use the bar graph, this is histogram. This is histogram. For the bar graph, nothing tell me not the width doesn't mean anything. I just do a bar. Okay, I just do a bar. It can be any size I want. As long as they look nice, kind of the same size is fine. But for histogram, it's very calculated. That's what I mean right here. The bar width for a bar chart or bar graph are meaningless. The width are meaningless. It doesn't really matter. But for the histogram, it means something. It gives you the width of each one. You understand? That's what it means. So the bar of the histogram must touch each other, and for the bar chart, there are gaps between them. We talked about that on Tuesday. We said that whenever you have bar graph, we have gaps. If there is no gaps, it's called a histogram. I don't say there's only one choice ascending by X for the order of the bars, while there are many choices of order for bar graph, for bar chart. Okay, so this is also just thing you can read about this one. So the idea is like we're gonna be using numbers like this, like with like 1, 2, 3, 4, 5. You have like a order for the X value. I mean for the original values, while compared to the other one, for the bar graph, it doesn't really matter because it's just as earlier, when I did the graph for the corporate, right here, I'm sorry, when I did the graph for the corporate, I did them in a different order. It didn't really matter, but I still have the same graph. When I did it right here, we still have the same graph. You see, as I would private. So nothing say that P must be first or C must be. I just try to follow the same pattern they have here. But if you want to be like more, sophisticated, you can just put it in alphabetical order. But it's not that very important. Okay, you can put alphabetical just like they did right here. Here it is in alphabetical order. You got C, M, P, and S. It doesn't really matter because they are categorical data. Okay. So whenever it's gonna have categories, one category is not better than the other one. You just, if you want to put in order if you want to. But if you have to do the Pareto chart, it has to be the order of the frequencies from largest to smallest. Okay. And so on. And then we have the, we talk about those things here. That's why I said there are many charts for the bar chart. You can use do however you want. For the bar graph over here, I can put B first and then D after and then C after. It doesn't really matter. But for the histogram, it's very important to put the bars from 0 to 10. It's very important to put it first. Okay, that's very important. Any questions so far? You see, I'm able to see the time. I don't see the time here. Okay, so let's talk about more. Now, let's talk about the pie chart. So we also use categorical data for pie chart, but the only thing is that it was a circle for it, okay? So he has a different size for the circles, okay? They are proportional to each other, okay? So the frequency, we talked about frequency before, but this case, because you got 260 degrees, you're not gonna have to build one, but you can also use the formula just for your own knowledge. For the angle for each one of them, how to graph it. So to get a specific angle for each one of them is the frequency divided by the number of frequency times 260, or the sample size, okay? So a frequency of the frequency of one specific element, okay? So here we have private, which is bigger, sergeant, etc., which is like the second largest, and so on, okay? Give me 1 second. Okay, so this is a quick presentation of a pie chart. We probably have some change to do some more exercises, okay? So we're gonna come back to these things after again, okay? So let me see. For today, we're supposed to be doing just 2.3, 2.3, okay? So there are some concepts I would like to see if I can just emphasize on them. Let's see. So I'm not finished with this chapter, so I cannot send them to you yet, but I'll send them to you afterward, okay? Let me see. I talk about the center. We're gonna talk about, again, we're gonna come back to centers again. Viability, we're gonna be talking about those again in the future. Let's see, what can I confess as on right now? The part chart, I didn't really talk about it, because what happens is that you're gonna see some examples online. Then you can probably do them. So let me look at some of the example online. Let me just stop sharing that for a minute and then share online. So let me go online for a minute. So Abby, you can see, Jennifer can see how to go to the class, okay? So let me see. So let me go to share my screen. So share. So this is whenever you want to go to your class, I cannot go as a student, because if I go as a student, I won't be able to access my thing. So what you do, you click on my lab and mastering. Or what you can do also, you can click on the syllabus right here. You give it that access to the homework section. Okay. This is the one class. No, this is the right class. So let me do student view a little bit so I can see it, because you show me things that you have to do here. Okay, so here you have the homework. This one say skill review chapter 2. Work on chapter 2. You guys are supposed to work on chapter 1 on your own, but look at chapter 2. But I did so do something in chapter 1. So let's get chapter 2 here. You can do like this. You click on it. Okay. Let me see. Then you can start doing the section right here. Do you see that, Jennifer?
Well, when I clicked on it, it sent me straight to person, and then it said to make an account. Well, I just click on the first one, and it sent me to another page, and that showed up like to log in into person.
Okay. Anyway, if so, probably you didn't have an account yet, but that's fine. So what did you try to go? Like, can you try to go to my lab and mastering, and that one? You click on that, my lab and mastering. What do you see? What do you see, Jennifer? Okay, I don't think she hear me. Ben, okay. So let me try to use that one too. I can go either way. So if I go here, I can just click that one right here. Then I go to one of my stuff here. Okay, this is my class. Oh, I'm able to go as a student. That's pretty good. This is my class. So what I can do, I can look at the assignments. Then if I'm able to go to my lab and start mastering, what do you see whenever you go there?
Okay.
You know what?
Let me see. So when I clicked on it, I did the pop-up again, but now instead of like say allow pop-ups, I put no. And then when I put no, now it shows the person thing, open my labs and mastering. And then I do see like how you see it.
Okay, you click on that. So you are able to go there too?
Oh, okay. So when I click on the person, it doesn't send me straight. It tells me what is the code of the class, so I can activate the pen.
Okay, so you know what? So the thing everybody, the thing I'm supposed to teach you today is over. So I'll put the notes for you soon, but give me some time to finish the chapter, and I'll put the notes for you. And also I'll try to make some of the video available for you when needed, okay? But not now. It's a bit too early now. So go try them. So I'm gonna end the video, and then no, not meeting. I'm gonna end the recording.